All right. All right. I want to welcome everyone, especially to class. So glad to be here. Yes, and it's a privilege that I'm having this distinguished individuals here with me in today's class. All right, so the course is industrial electrical safety. Industrial electrical safety, and it's going to be a very, very engaging and a very, very interesting class. All right, so this training is brought to you courtesy QC Concept Training Company Limited, just as you have it on display. So we are a professional training firm. We are into professional trainings that cut across various fields and industries, the engineering field, the manufacturing field, the financial sector field, the management field. Yes, most importantly, one of our core areas where we train on. And when it comes to soft skills, we are also very, very much versed and available in that aspect as well. So our trainings cut across board. So if you have been a part of our trainings at one point or the other, then you can attest to what I just talked about. So our firm CFC Concept organization is inclined towards productivity. So any training that is going to bring productivity about in any organization or in any of our clients' businesses, then we are open to such training. So you can engage us in order for you to be able to improve on your organizational productivity as an organization, as a business, or even as an individual. So part of us achieving our goals is bringing trainings like this to your door steps. So some of us who might have at one point or the other engaged or been a part of our trainings before can attest to the fact that yes, when it comes to delivery, when it comes to quality of training, yes, we are one of the best. So I'm welcoming you to class officially. Yes, my name is Kehinde Samson Ogumiwa. I'm going to be your host. I'm going to be your moderator for this professional training. Yes, industrial electrical safety, like I did mention that the train is. This is not the first of its kind that we are running. We have subsequent series on industrial, or let me call it batches on industrial electrical safety that we have had in time past, even before now. So you having the opportunity or access to this training is a very, very good opportunity for you. And I'm so glad that you are here with us. And I want to congratulate you that you have tapped or taken to this opportunity that we have given out. All right. So we can't really overemphasize the importance of industrial electrical safety. But before I go deep into the details concerning what the course is all about, what I want you to do for me, just as you are joining in this class, is please go to the chat section or go to the e-message section, as the case may be, on whichever platform that you are joining us, either via the Google Meet link or via the YouTube Live link. Go to the e-message section, tell us your name, tell us where you are joining us from, and tell us what your expectation of this training is. So quickly, let us do that. Let us introduce ourselves. I've introduced myself. My name is Kehinde Samson Ogumiwa, an administrative officer with COC Concept Training Company Limited, and also a trainer under this organization. So I want you to please introduce yourself, tell us your name, tell us where you are joining us from, and tell us what your expectation is. Yes, I want to believe that yes, the majority I'll be having in today's class are those who are engineers, who are within the engineering family or within the engineering profession. And trust me, all that we are going to be discussing in today's class is revolving all around that. So please let's keep the introduction coming in. Thank you very much, Friday, who is joining us from Lagos. Friday, David. Thank you for joining or for being a part of this class. So please, if you have those who haven't joined in this class yet, please let us encourage them. Let us remind them to join in. We will try as much as possible. We'll try our best to send reminders to you all as well. So please, if you don't get reminders via email, you will definitely get the reminder via the WhatsApp group or the prompts on your Google or mobile device. All right. So, like I did mention, the course is industrial electrical safety. Yes, we cannot really overemphasize the importance of industrial electrical safety or safety when it comes to dealing with electricity in the industry. Because from record, there's a great percentage of incidents or hazards that are related to electricity that the industrial environment is really suffering from. So many injuries, many accidents that we encounter, that we experience in many industries, in many organizations, are really due to mismanagement of what of electricity. When we don't take into cognizance the safety aspect when it comes to dealing with electricity. So all these areas are what we are going to look at. What are the hazards? What are the things that contribute to electrical accidents? The things that contribute to electrical incident. Let me use that terminology at the workplace. So what are the mitigations that we need to put in place? Mitigation effect that we need to put in place in order to what mitigate against what electrical hazard or incident. So all these are what we are going to be looking at in today's class. Yes, and trust me, with us in today's class, we have a distinguished resource person who is going to be taking us down the lane in this course of study. So it's none other than Mr. James Fanny. He is very versed when it comes to the field of engineering, and it comes to the field of safety. He is one of the best. When it comes to delivery, passing on the knowledge of safety as a whole, is actually his style of teaching, his style of lecturing or training is dynamic. Let me put it that way. So trust me, for many who have been a part of his classes before, if you have been following any of our training trends, you will admit or you are agree with me that yes, his training style is actually very, very dynamic. And when you are in his class, it is easy for you to grasp, to understand all that is what he's talking about, or all what he wants you to understand. So he's going to be joining us here shortly. When it comes to reciting his profile, he always tell me not to, really go. It doesn't need that. All he just wants is to be able to pass the knowledge, and for people to be able to get equipped by the knowledge that he is dishing out. So trust me, in today's class, we are going to be enjoying the benefits of he being on board in this training. So I want to welcome everyone once again to class. All right. Let's keep the introductions coming in. I've actually seen only a few people who have done that. Yes, I want you to please introduce yourself. I can see Kwabena Daniel from Ghana. I can see Duragbemi from Ogun State. Thank you. I can see Etido Frank from Bayelsa. Okay, I can see Marvin from Port Harcourt, Amosu from Lagos, Joshua Kumasi from Ghana. Okay, thank you very much. Let's keep the introductions coming in. Okay, so this training is scheduled for 2 days. That's today and tomorrow. And as such, okay, Augustine, I'll come back to you. Augustine, I can see your hand. I'll come back to you. Thank you very much. So as such, we are going to see what we can do within the span of the 2 days that we have for this training. And at the end of the day 2, that is at the end of tomorrow's class, we are going to be having our assessment. So for every part training that we do like this, we have assessment, and that is going to test your understanding of what has been taught. Yes, and for the lots who have been asking, is there going to be certification for this training? Yes, there's a provision for that. Yes, and the certification wouldn't require you to go and break the bank before you get it. What we are after as a business, as an organization, is to be able to help individuals, be able to help businesses to achieve that desired business outcome or achieve that career goal of theirs. Yes, and we are focused on achieving that goal. And thankfully, this is one of the mediums whereby we use in reaching that goal of ours as an organization. So please, I want you to join this learning journey, join or tap into this very glorious opportunity that you have put out there. If you want to join or attend any safety training like this out there, you know how much you are going to pay before you can get this knowledge or this certification. But yes, we are making knowledge free from our own end. Yes, what we just want to achieve is to make sure that what people do what is right. When it comes to safety, people have the right safety ideology and the right safety culture when it comes to what discharging their activities around the work environment or around the workplace. All right. So, Mr. Augustine. Mr. Augustine, I can see your hand. All right, moving on. So let's keep the introductions coming in. Our resource person is already here with us. He's here with us already. So in a few moments from now, you are going to be hearing his voice. Okay, so we are streaming live on YouTube. For those who don't have access to this Google Meet classroom link, yes, you can still join the training, join the class via that medium. And trust me, every of your questions, every of your contributions are also going to be attended to. So please, if you have any question, if you have any contribution for me or for the trainer via that medium, please drop it in the message session. Some people are saying the YouTube link is not opening. Well, we have quite a number of people who have joined in via that medium. So perhaps maybe you need to check your network. So YouTube participants, Adeoti, Samuel, Gabriel, Madugu, Joseph Oladapo, I want to welcome each and every one of you to class. Kingsley Umar, thank you for joining us. All right, so let's go down to the business of the day. So the course is Industrial Electrical Safety. Safety. There's a very, very interesting safety song that perhaps maybe at the end of the class, I'm going to sing it to our hearing so we can learn it. Yes, the safety song has been a mantra that I hold on to for quite a number of years now. Yes, and it will be so good if I can also pass that, that knowledge. But that will be after the whole training. Okay, so but today let's get straight to class. All right, our resource person is here with us. That's Mr. James Faniyi. So please, we are going to be hearing his voice shortly in a brief or few moments from now. Mr. James is going to be coming on board. Do we have anyone who has attended our trainings before now? Do you have anyone? If you have attended our trainings before now, just drop it in the comment section and let me know the training that you have joined in. Let me know any of our trainings that you've attended. So just drop it in the comment section. Do we have any? All right. So without further ado, the next voice you'll be hearing will be that of our resource person, Mr. James Faniyi. Okay, so please let's give him our undivided attention. At the end of the class, you will be given the opportunity to ask questions. So please, while the class is ongoing, if you have questions, just note it down. At one point or the other, we'll call on you to make your contribution. So please make yourself available. All right. So thank you very much, everyone. Let's start with the class.
The training is industrial electrical safety, and I'll be facilitating the training with you. I've been introduced already, so I don't need to do that again. My name is Faniyi. I don't like telling people my profile, but there's so much interested you can find out. So I've seen that we have a lot of people who are actually electrically inclined among us. So that's fantastic. That will make the training easier for me. And if you are not also an electrically grounded person, or you don't have the background in electrical, because a lot of people that saw electrical safety, they will think that, oh, it's those people that do the electrical, and that would be a wrong mindset. When it comes to industrial safety, it is all encompassing. Industrial safety, affect you either you are working in a particular department or you are working in another department. In as much you gain access to the factory or you gain access to the industry, you enter from the gate. All hazards that are present are also what? Yours. So you can prevent them, you can guide yourself against them, and you can as well mistakenly or innocently or ignorantly expose yourself to those hazards. And that is why you need to have the knowledge of the dangers around. You need to have the sound understanding of things that could go wrong at work. Either you are actually interacting directly with some equipment or not. You need to really be aware. And it's not really, especially in this part of the world, I mean Nigeria or Africa, sometimes I don't blame employees because when there's what we call induction, when you get a new job, irrespective of your experience, when you are moving from a company to another company, transiting from one company to another company, if you like, write 20 years work experience in your CV, you need to be retrained. You need to still go through induction because the environment where you are coming from is not the same with the environment where you are right now. So there might be some things that were not what dangerous or that do not really pose high risk where you are coming from, but here in our own company, maybe we have a history with it. Maybe a lot of people using a particular machine, they have had injuries or cases, of accidents with it. So we need to actually alert you also. We need to really give you another orientation because there shouldn't be a situation where a worker or an employee will be involved in an accident and then you begin to blame the company saying that, oh, I was not told, I wasn't aware. For instance, let me come down to many of us, especially the electrically oriented people, those who are engineers. Because you have little knowledge of engineering or electrical, sometimes it tends to even do things that are against electrical safety. I think that there are people back then that their own fan inside their room, they are the only one that can operate it. You dare not touch the switch in their room because they are the only one that can operate it. A lot of what expose live conductors in the room of the so-called electrical engineer, just because he believes that he can always find his way. He can be careful. Forgetting, days that he might be stressed or he might be forgetful about what was. There was something I saw which was very, very wrong with electrical safety. And where I saw it, I was actually a lot disappointed. I could remember, my very first time of going to a power holding office, NEPA office, so to say. So, and reaching there, what I saw, I could not even say that I was in an office where they have what electrical work ethics. If you look at the conductors, the way conductors were left flying here and there on the distribution box that they themselves they are using to supply their own building. It was left open, a lot of loose cables, a lot of twisting, joining that you dare not call another person who was not there or who is not actually was familiar with that. You dare not call that person to come and troubleshoot that particular circuit or trace any fault. It's going to be in soup. I've had the situation before also where people do connections. We have practice in engineering, electrical engineering, so to say. You say, okay, let's use red cable for live, let's use black cable for neutral. It is not that if you switch the cable, it will not really work. There won't be supply. No. But it's because there is an ethics, there is regulation, there is, and all these things, they are all to uphold electrical safety, such that if I am coming to troubleshoot, a particular connection, I should be rest assured that when I see red cable, I know that it's carrying light. When I see black, I know that it's carrying light. But OYO is your case if you work like that, especially in this part of the world. Because you still have to carry your meter. I've seen where the red cable was coming, carrying live circuit, and then maybe the wire was not enough. We just join it with another black. And then by the time you see the output, you will see black. You can't be wondering which one is live, which one is this, and all that. That's why you must always have your meter. So enough said about that. I don't really want to be too deep into the electrical thing and all that, because we may have people that are not electrically oriented among us. So let's get started on the training. Okay. Now, the first thing that we must know is that when it comes to industry, there are people who we call, qualified electrical workers, and there are people who we refer to as unqualified electrical workers. Who are the qualified electrical workers? I've seen so many here, perhaps, okay, that they said, oh, they are electrical engineer, or maybe they have the background in electrical engineering and all that. Now, people who have the knowledge, who have the work standards and the regulations guiding an electrical work in a particular industry, you can refer to them as what? Qualified electrical workers. These are not just people that have ideas. These are people who have gone through trainings or who are actually what? Professionals, understanding what electrical what connection is or what an energized equipment is. Now, another thing, based on the electrical standard that we must understand, a qualified electrical worker may not be a generally qualified electrical worker. What do I mean by that? Somebody may be qualified on a particular equipment and yet is not qualified on another equipment. No, both of them are what? Electrical equipment, or they're actually using electricity. So you cannot say generally this person is just qualified. Take for instance, you are saying that somebody who can actually work on your socket inside your room because it's an electric, is certified somebody that can work on electricity. So because that person can work on your socket, they call him to come and work, come and climb the poles on the street. That would be definitely wrong. So somebody might be trained such that he can what? Climb what? He can work at heights, connect what? Cables from one pole to another, from one joint to another joint. And another person might be trained that domestically he can actually what? Troubleshoot and work with what electrical gadgets in the house. So there is nothing like generally qualified. There is only relatively what? Qualified electrical worker. Now, who are the what? Unqualified electrical workers? These are the unskilled people. And in most cases, a trainee, okay, an industrial trainee can also be referred to either unqualified or qualified. He is only considered qualified if he is working under a supervisor who is actually monitoring what is. I can recall my Dangote Academy training. I went through Dangote Academy training, and I was so lucky to be among the first sets that entered into that training. And because of my passion for power, I actually chose electric. Had a lot of options. Now, for the first few months in the training, we will go through the theoretical aspects in the classroom, and then they take us to Dangote Obajana cement plant in Kogi State. Now, anytime we are working, all of us we actually attached to what? Indians. Okay, we're working with Indians, and they were actually what? Saddled with responsibility to train us. Now, the training is that sometimes they may not even allow you to actually do any connection. For a while, you have to keep watching. You keep watching what they are doing. At a point, they can give you what? Flyer. They say, okay, twist this together, take this close, you'll never do this. At that point, you can't call us qualified electrical workers because we are still under what? The supervision of someone. You can't work on your own. Anything can go wrong. And that's why electrical safety is very important. Electrical safety can lead to what? Death, just within what? A microsecond. Electrical safety is so important to the extent that if you know how many lives, that electrical accidents, on job are taken, okay? If you know how many lives that these, there was a statistics of this, being done, that across industries, every day, a life of an employee, across industries, every day, a life of an employee, at least a life of an employee is being lost due to electrical, accidents on the job. So you can imagine that is every day, even as we are talking right now, today, if you do your statistics all around industries, across industries, you must find out that what electrical, faults or electrical accidents or electrical hazard has taken what or claimed the life of an employee. When you make mistake when it comes to what electrical faults, you can actually lose your life and at the same time take many lives with you, along with you. Mechanical faults or other, interactive or physical faults or safety. Yes, they are also dangerous, but we have seen some cases where people put their hands inside a rotating machine. They just lose their arm. Maybe they use the right arm. The person may still stay alive. But if it comes to electrical, you may not even live to tell the story. You won't be amputated in most cases. It's not like you are going to be you are going to lose one hand or lose one eye. In some cases, you lose life. And that's actually what the extent, of the dangers that we have in electrical fault. So when we talk about qualified and unqualified electrical workers, you must know where you belong. That does not mean that you are not at risk, whether you are qualified or unqualified. But what we are saying is that if you are not qualified, the only thing that you bother your mind with now is how do you protect yourself against electrical faults or electrical hazard. But if you are such a person that is qualified that you interact with it, yes, yours also is also a question of how do I protect myself when I'm working on an energized equipment. So these two things are very, very important. You need to know where you actually belong. We don't encourage people who are not trained to work on electrical equipment to just say, oh, I'm experienced, I can do it. That is against safety rule. But even you as a mechanical man, on the equipment where you are working, of course, it's going to be electrically energized. So you need to be aware of the dangers, and you need to learn what to do when the dangers also arise. That's what we are talking about. So let's move very fast. You need to familiarize yourself with the general requirements of the standard. Okay? You need to identify common electrical hazards. You need to understand the definition of electrically safe work conditions, recognize electrical equipment defects and hazards, understand basic wiring design and protection, and identify wiring methods, components, and equipment for general use. Don't worry, the material is going to actually provide it. So if you are not actually following with what we are actually on display, there's so many things because we are not here just for theories. I'm actually here for us to actually have practical views of what we are discussing. Now let's look at causes of electrical accidents. What are the causes of electrical accidents across industries? Now the first one I will be discussing is unsafe equipment and installation. There are so many equipment that due to poor maintenance, they may actually become unsafe for you to use. When we are using the word unsafe, we are talking about perhaps they are not adequately maintained. Back then in some industry, I will not be mentioning names of companies. There are some times that employees who are supposed to maintain a particular machine might actually forget. Okay, they might forget. There are some machines that every 10 days, every 15 days, okay, that you need to actually maintain them. So sometimes they may actually forget. And when you do this, just know that you are putting the life of the person working on that equipment, you are putting the lives of those people, you are putting it at risk. Because interacting with that machine will now become dangerous. It will become unsafe because there is an unsafe, maintenance culture already that you as the person who was actually in charge of maintaining that machine has already promoted. So you need to know that from unsafe equipment and installation, you can actually have electrical accident. This can actually result to electrical accident. We also have what we call unsafe work environment. Unsafe work environment means that if we are working, on a day that it does not rain, that environment will be safe. But on the day that it rains in that environment, it may be unsafe for us to work in that particular environment. If you are working, and the land or the ground or the floor where you are working is wet, that has become unsafe work environment for you. Meaning that there are dangers all around. And if you are also working with an unsafe work practices, what are the unsafe work practices? There are procedures across industries, and every industry have their own procedures peculiar to them. That if you are going to work on a particular equipment, these are the process and procedure that you need to follow. So when these three things, these are the three causes of electrical accident. Number one, I mentioned unsafe equipment and installation. Number two, I mentioned unsafe work environment. And number three, I mentioned unsafe work practices. All these, result to electrical accidents. Now look at the list of unsafe equipment and installation. What if you have faulty insulation? If the insulation, of the particular device or equipment that you are using, if the insulation has been broken. Now, what do we call insulation? For the sake of those people that are not electrically grounded, insulation is those things that you see as rubber. You can call it rubber, that actually protects, you from directly touching the conductor. So it is the insulation material that we refer to as insulator. So that we are talking about faulty insulation. If you have experienced this before, there are sometimes that if you forget that the plier that you are using has already had a cut or a breach in its insulation, you may actually receive a tingling feeling, like a tingling feeling, a tingling sensation when you're working on electricity. To just bite you a little, and then you will see that it's because you are using a 40 watt equipment. Now, I also had another experience back then when we were supervising the Ibese cement plant. That Dangote Ibese cement plant. I was so lucky that when they were building the Ibese cement plant in Ogun State, part of us as Dangote academy candidates were actually used to also supervise the installation of the electric motors and other electrical gadgets. Now, if an electric motor is of a particular kilowatt, and you want to actually connect the earthing of that electric motor, there are some of them that you can connect the earthing cable to the body of the motor, and there are some of them that you can actually take the earthing cable to the ground based on the rating of the electric motor. At least anything from 50 kilowatts upward, you should be able to connect the earthing cable directly to the ground so that it can be safe. So these are practical explanation that you can have for the faulty insulation. Also, by improper grounding, I've mentioned that loose connections, that this can also cause issues. When there is loose connections, and that's one of the things that the electrical people do during maintenance. They have to retighten all the connections. They have to be sure that all the connections are firm and tight. Because if this is not properly done, there might be spark. And in some cases, we call it arcing. There might be spark. Let me show you some of those the pictures to all those things. So you can see loose connections. Let me get you a picture of spark that you can actually feel when the connections are not tightened enough. I should have one of those pictures here. Now, if you can hear me clearly and you are in tune with me in this training, either you're on YouTube or you are with us on Gmail, just go to the comment section and put "I'm with you." I want to be sure that I'm actually watching it here. So you can see this. So this is a loose connection. Can you see this image right now? This is a loose connection. So you can see this is a loose connection. It is not properly tightened. Okay. And then the wire may actually touch. There may be live cable touching neutral cable. A lot of things. It may actually touch even the body of the equipment, and then that might actually result to the fire incident if not properly controlled. So if you are with me, I want to see you typing "I'm with you." I'm with you. I am with you. I am with you. Thank you so much. Thank you so much. That's Chidima. Thank you, Chidima, an electrical engineer. That's fantastic. Now let's continue. Defective parts. Okay. Are there some part of the equipment that needs to be replaced, or that maybe have been repaired before and they are supposed to be replaced? Most of these things happen in industry. Sometimes, because of the corruptions, there are some part of the equipment that they will tell you, "Oh, replace this equipment." But because the person in charge wants to manage money, he will carry the old one, repair it, and then will install it back, instead of him to buy a new one and replace. It does happen a lot. And you that you are working on equipment, you don't know that there is a particular part of that equipment that is already defective, that is not working properly. This can actually become an unsafe equipment, okay, and then it can result to an electrical accident. I've mentioned ground faults. Unguarded live parts. What about unguarded live parts? Okay, let's see some images of that. Unguarded live parts of cable. When we say guard, there are some equipment that the guard is just to separate you, from the part of the equipment that can give you a shock or that can result to an electrical accident with you. Okay, these are guards. Look at this cover. Okay, this cover, you can see that this man, before he's actually touching the switch, he raised a particular guard. He raised it up. This is a guard in case if there are electrical faults or whatever that may actually occur here. This guard is actually protective. It's interfacing between you and the machine. Okay, there are so many other fantastic images that you can see with guard, okay, being used. Okay, when we move on, if I see any of those images, I will actually take that up also. So we have unguarded live part. If the part is not guarded, definitely the equipment becomes unsafe. Underrated equipment. What about underrated equipment? When you have some equipment which happens a lot to a lot of people who believe that they have experience, you just look down on some equipment. You underrate them. This one cannot kill me. What can happen to this one? This one cannot kill me. But it does happen. As small as your phone is and the voltage in your phone, there are a lot of people who have not used phone, safely before, and plugging their phone while it is actually in use. Okay, and then there are many lives have been lost due to that, and there is a lot of people that had terrible story totally tell about that. Okay, so let's look at this. What are the unsafe work environments? Unsafe work environment. What makes the work environment unsafe? When you have flammable vapors, liquids or gases, the environment becomes unsafe because any little spark, can result to explosion, and result to fire incident. When you have a corrosive atmosphere, okay, that's an unsafe work environment. When you have wet, I've mentioned this before, wet and damp locations, this is also unsafe work environment. All these can actually lead to electrical faults or they can lead to what? Electrical what? Accident. What about unsafe work practices? For example, you are working on an energized equipment. When we say energized, we are talking about what? Equipment that is still plugged. This is so common. And mind you, you have to, ensure that your safety is prioritized. Because I've seen a lot of people, and I've heard about a lot of people, who actually wanted to impress their boss, but they lose their life in the course of, demonstrating loyalty in a stupid form, in a stupid way. How is your loyalty? How can it become stupid? It becomes stupid when you are putting your life, at risk just because you want to work on an equipment. What is the normal practice? The normal practice of electrical safety is that you should do all you can to ensure that the equipment is what? De-energized. De-energized means that what? You remove what? The power supply from it. When you are working on any equipment, it should be a dead equipment. Except some tiny cases. There are some tiny cases, exceptions that we normally have, where you will not have to what? De-energize what? The equipment. But there are other procedures that you must, undergo, which in the course of this training is going to be mentioned, for you to actually guarantee what the safety of the person working on the equipment. But the first thing, the foundation is that what? Every electrically energized equipment must be unplugged or de-energized when you want to work on it. So failure to de-energize electrical equipment when inspected or when you are working on it, that is an unsafe work practices. I've had a lot of people who testify to this. I have a friend back then in the academy, so he was working with his boss and his Indian boss. And normally, if you have interacted in the electrical in the industry before, when you want to talk about some equipment, let me share my whiteboard for us to see what I want to actually demonstrate. Now, there are things that we call push button. Call them push button. You see them, okay? Sometimes you see green, red. You see a big one, which is an emergency, okay? And then let's say the machine that you are operating is here. So this is what happens on the field. This is the switch. This is the machine. And then you are the personnel that want to perform maintenance on this machine. The requirement is that you must have gone to electrical department, okay? Electrical department. Now, what will they do in this electrical department? You go and obtain what we call line clearance. Line clearance is that you are telling electrical department, I want to work on this so machine. Please, I need you to disconnect this machine for me for the period of time that I will be working on it. That is the normal practice. You see where this knowledge is very important for even those people that do not have electrical background. Because you must not work, you should try as much as possible not to work on an energized equipment. But in most cases, especially in our industries, especially in this part of the world, there will be some proposals which would actually want to force you that you can manage now. Don't you have flyer? Don't you wear your glove? All these are not enough for you to say you want to go and work on an energized equipment, which you're supposed to take line clearance for. Or you know that at the control room, because there's always what we call control room, especially if you are working in an automated plant, just like a Dangote cement plant. The plant is fully automated. So the control room always starts the equipment. Every equipment, they can start it remotely. That is, without leaving the room where they are, they can start it due to programming. They can start it on the system and say, this particular machine should actually start. And it will start wherever it is on the field. They are only just to press start button on their own computer. So in the control room here, they can remote start this particular machine. So my friend and his Indian boss, they were working on a machine like this. And if I could recall, the machine was 660 volts. I'm still going to explore that. For those that may not know what we are talking about, when you're talking about 660 volts, that's even more than a three-phase connection. Okay, at least in three-phase, you should have like 415, or maximally, let's say if you have a very good supply, let's say 440, or 415 is usually what the actual work practice. Sometimes you can have less than that, but if you measure 415. So now imagine somebody working on the one that has to do was 660 volts. So he told the Indian man, because they are working on an electric motor, they want to actually perform the maintenance, and they have to open the terminal. Opening the terminal means that what you are going to be using plier, you are going to be using spanner directly on the conducting part of that machine, electric motor. So he told the Indian man that please let us go and take clearance. But the problem was that the Indian man supposed to have done carried out maintenance on that machine based on the company record, but he missed the particular day. So legally, he cannot go back to electrical now and say he wants to take line clearance. They will ask him, this machine is supposed to have been maintained last week. Why didn't you do it? It's going to become a case on him. And because of that, he wanted to play a smart one, and he himself knew the danger in it. So he was not doing the job. He was just standing and using mouth to control this, my friend, that he should do this, touch here, touch there. And that one was saying that, so where is the line clearance? He said, no. If you have worked with them before, no, you line clearance, no need now, you do fast. We live here. My friend also told him, okay, there is a provision for emergency switch. This emergency switch on the plant, when you press it down, the control room, they will not be able to start that machine. What they will be seeing on their system is error. Until you come back to this place, okay, to go and release this emergency switch. So he told him, okay, let us put emergency switch. The Indian man also knows that there will be question on who put the emergency switch, because the control room, they are going to say that they had a delay of 5 minutes to start that particular machine, and that's going to be an issue, and somebody must answer that question. So he also denied him. He said, no, you cannot put emergency switch. You should just quickly work on the electrical. Behold, luckily for him, he had already finished the maintenance. He was just covering the terminal of the electric motor, and that is how the machine started like that. He told me of his experience that he nearly even slapped his boss. Just imagine if it was when he was using spanner on that particular conductor. The story wouldn't have been the same like I'm talking about today. It would have been a sad story. But luckily for him, he escaped it. That can be you, that can be anybody. But what is his right? He has his right that he could have maintained his stand that I cannot touch an energized equipment unless we go and take line clearance. I've heard of funny story, and they are not really funny, they are sad story of NEPA officials, okay, who try to work on a live pole, high voltage, where they're supposed to call office and say, oh, take down this particular line, we want to work on it. But because they have also missed the maintenance, you just see that it will be somebody they will use as a lab rat. They say, oh, you are the junior staff here, you go. And you want to work. If you have learned, you have been trained, they will tell you that don't you know anything, they will strike you like that. And you want to show that you know your job. You also want to prove some points. And stupidly, foolishly, the person moved down there. I had a story of a man whose wife just gave birth, was a NEPA official. This person is known to me, is known to our moderator, Mr. Kenny. So I think I had that story from even Mr. Kenny on the day that we actually were discussing about safety and all that. We're just chatting about it. So he told me of his about this friend of his. He was a colleague to him, okay, and then he was a school colleague back then in school, and he's a very promising guy. Okay, the wife just put to bed, very small baby. So it was a NEPA official, and then they tried him like, man, come on, climb this thing. When I was like you, I used to do this, I used to do that, and he climbed, and that was it. The connection was actually taken up at their office, not knowing that somebody was working on the line, and he died instantly. That is an instant death, and that's why electrical is actually electrical accident is very dangerous. It does not give you second chance in most cases. Now, what happens when you have what use of tools or equipment too close to what energized parts? Okay, look at these connections. We're just using this as an example. Look at this overloading. Okay, so that's what we mean by overloading what circuits. How many of us actually still do some connection like this? It can result to, if you go to bed with this, anything can actually what go wrong. And also in plant also, there are junctions that are actually what usually being what overloaded. Now let me show you some images of what line clearance. Okay, you see people working on. Now what they are doing here, okay, they are work on all these kind of breaker in the company before. So they will bring you to this breaker. Okay, they are probably tracing what the reading or tracing the supply. They have to bring this down. But most industries, I don't know where you work, you see this kind of breakers. All of them so have a machine on the field that they actually will supply. So if you are actually working on a particular machine and you have to take for line clearance, you as a mechanical man or whatever will be your department, you have to follow the electrical man to this what breaker here. In your presence, you must take it down, and in your presence, you must actually what put the word like I'm going to talk about that when I'm talking about what. So let's move on, because we do have a lot. Okay. Now let's look at electrical safety model. What is the model for electrical safety? The model that you need to actually what follow. We're talking about what the pattern that you must actually what follow for electrical what safety. Now, what is the pattern? The first thing is that you must learn to recognize hazards. It becomes a problem when you don't know that something is wrong. As an employee, either you are an electrical worker or you are a mechanical worker, or irrespective of your work department, even if you are working in bank, when you see what is wrong, you should know what is wrong. What is the definition of an hazard? An hazard is anything that poses what a level of what risk, okay, to either life, property, or environment. That is an hazard. An hazard is anything that poses a level of risk, okay? Anything that poses a level of risk, okay? That poses threats either to life, okay, to environment, or even to the equipment itself, okay? Anything that has potential to cause harm is an hazard in the industry. So now, talking about the electrical hazard now, anything that has a potential to cause electrical accidents, anything whatsoever that has a high what, that has a potential to cause electrical accidents, that is what an electrical hazard. You need to learn how to recognize them. That's how we say that to avoid injury or death, you must first understand and recognize hazards when you see one. Now, when you begin to see, some of these images, okay, that I have been showing you, look at this. When you see something like this, you should know that this is what an electrical hazard. For crying out loud, how can somebody connect cables like this and leave them? No tape, no insulation tape, no covering, and they are exposed. That is hazardous. So when you see this as an employee, either you are working in the electrical department or not, it makes sense, okay? It makes a whole lot of sense for you to be able to see this and say, oh, this is wrong. This is against safety. You need to actually recognize it. Look at this connection here. What do you think that is the problem? Okay, there are many people that when the plug is bad, they remove the plug and they start connecting the cable directly into the socket. That is against the ethics of electrical safety. That is an hazard. When you see something that is wrong, when you see danger, ability for you to recognize that danger is what we call recognition of hazards. So electrical safety starts with you becoming aware of what is wrong. Okay, you need to see it and you need to identify it. Look at this. This plug is burnt. Okay, when you see what is wrong, you need to what? Recognize it. When you see bent poles, some electric poles that are already what? Bending, towards the ground, you know that what? Oh, this is wrong. This needs to be what? Corrected. Okay. When you see somebody walking like this, okay, let's see if she's using what? Electrical shield. Okay. When you see somebody that is working on electrical, equipment, and perhaps is going to be twisting some conductors together and is not putting on his glove, it is very, very wrong. So look at this man here. That's a very good practice. Let me zoom it for you to actually see the image. Okay, it's a very good practice. Okay, you can see is what it's an electrical goggle that's protecting his eyes against what hacking. He's putting on his helmet. That helmet might not be due to what mechanical impact. There are sometimes that what people's heads get what in connection with light cable when they are working, when they forget themselves. Especially if it's a particular joint box where you need to bend, be at a particular elevation or angle of depression to the what? To the equipment that you are working on. You need to protect your head. Okay, because you can easily forget yourself. So you need to recognize hazard. The next thing that you need to do is for you as an employee to evaluate the risk. Oh, this thing is dangerous. How dangerous is it? That is the evaluation of the risk. Oh, this thing that I'm doing is risky. Let me now evaluate how risky is what I'm doing. What could happen if I get entangled with this electrical conductor? What will happen to me? Will it just be a shock that I will receive? Will it be a total electrocution? Will I actually suffer burns? All these things are evaluations that you need to do. Then, now that we now know the hazards and we have evaluated the risk, okay, then the next thing is for us to control the hazards. And there are so many things for us to do to control the hazards. There are policies, that's administration control. Okay, there are cases of producing guard on the machine, such that the part of the machines that can actually open the worker to electric shock or electric fault or electric accident can actually be protected and covered. And then there are what we call PPE. So we'll look at that in this subsequent slides. So let's look at the hazards. Recognizing the hazards. What are the most frequent electrical hazards or injury across industries? So let's look at it. Contact with power lines. That's when you touch the power cable that is actually supplying a particular equipment. I hope you are with me. Anyone in the house? All right,
I'm with you, sir. But nothing is displaying.
Oh, you are not seeing?
I'm not seeing the screen, sir. Nothing is displaying.
Oh.
No,
Everybody here my screen? Who is seeing my screen?
yes, we are here.
Now, when you scroll it, you see.
Okay, I can see my screen.
Wow.
All right, thank you so much. So, we are looking at the frequent causes of electrical injury or death. The first one here is contact with power lines. I've mentioned that. I said when you are touching, or when you come in contact with the power cable. That's the cable that is actually supplying the particular equipment. Lack of ground fault protection. There are some times that what we call earthing. Earthing is, I have an equipment like this. Okay, let me show us in the whiteboard. You can have an equipment. Okay, if this is our machine, because the ground, that's the earth, is a good conductor of electricity, there are sometimes that the body is actually what? Connected with the cable, with the conductor, okay, buried in the ground. That's what we call earthing. So what happens when there is fault in this? When this actually fails, because it can fail. That's what we are talking about. What happens when it fails? That's what we are talking about. What? Ground fault protection. Okay. Another thing is part towards ground missing or discontinuous, equipment not used in manner prescribed. Now there are sometimes that, especially in some industries, it's so common. Every manufacturer of equipment will tell you how to use it. And you will agree with me that most of us in this part of the world, we have some form of maintenance culture. Most of the faults that are on machines are due to what? Poor maintenance culture. Because we are not properly maintaining those machines. So when the equipment is not properly maintained according to the to the prescriptions that the manufacturer has given, then there is going to be a lot of hazard. So you can actually recognize that as an hazard. Improper use of extension and flexible cords, that is the connections across the plant, when they are not properly, when you don't use them for what it's actually meant for. If, for instance, you can't. How many of us connect? How many of us plug? Please don't lie to me. Okay, I need somebody here to tell us, how do you differentiate a 15 amp socket and a 30 amp socket? Is there anybody here that can try?
Yes.
Good. Okay. Okay. Ali, go ahead. Ali, please go ahead. Tell us.
I'm going to simplify if you want to speak. Simplify if you want to speak. Okay. What are you adding for? You can unmute your mic. What are you adding for? I think to differentiate 13 amps from 15 amps. Number one, all electrical appliances are power rated. From their indication, we can see that. And from physical appearance, 13 amp socket is usually in a rectangular, I think the pin out. Why the 15 amp socket usually to be in a cylindrical form? That is the two I can take to differentiate. Number one, indication, and then number two, by the physical appearance. Thank you.
Okay, thank you so much. Now, what I want to ask now is that, how many of us plug our, I'm going from industry, we are cutting across. Okay, I'm just using what anybody here that does not even have electrical background will actually relate with. Because I'm coming low to those illustrations. How many of us plug ions on a 30 amp socket? You risk it, like for a while you use it. Is there anybody here?
Yes.
Okay, you do that. Who is that?
So, Jola,
so why do you do that?
I don't know.
At times when you are in hurry. Okay, that's what I'm talking about. Okay, so when you load, when you load a particular equipment, that the current rating is more than the source, then there is a problem. Okay, there can be a problem. Okay, and if you are lucky, it might be that you just replace that particular source. And if you are not lucky, it might result to something else, especially if you are not the one handling it. If it's somebody at home, or if it's somebody in the industry or in the department that is actually interacting with that machine, you understand it anytime you want to use it. You are always careful with it because you know that what you have done on it is dangerous. But that person might not be so careful. That's what we are talking about. So that's why this is talking about improper use. Careful planning of our safety procedures. We need to know that this also helps in what? Reducing what? The risk of injury. When you plan the safety what? Procedures, when you have a careful planning, towards the safety procedures, then it can actually what? Reduce what? The risk. And when there is a decision to use Lotto, I'm going to be explaining this Lotto later. When there is what? A decision that a company say, oh, we are going to be operating what? Lotto on any equipment that anybody wants to work on. Then this also what? Facilitates what? Electrical safety in what? In companies. Electrical hazards. What are the hazards that may result from electrical fault? Explosion. That's the very first one. There can be what? Explosion due to electrical fault. Because you should know that what? Electricity will provide ignition. Okay? When you have a flammable atmosphere, or when you have what? Explosive mixture in the atmosphere, they just need an electrical spark, just a little spark. And then you have what? Everywhere engulfed with what? Fire or exploded. Okay? There can be what? Fire incident. Unlike explosion, you can also have what? Fire incident due to what? Electrical what? Fault. And in fact, if you have undergone fire safety before, because it's part of the curriculum of this what course, fire safety, we are going to talk about it. Fire safety will show you that one of the dangerous type of fire or class of fire to fight is the class of fire that is caused by electrical, fault. Because aside the fact that you are fighting the fire, your life can be in danger. You can also be exposed to what? Electrocution. You can be exposed to what? Electrical hazards, even while fighting the fire that is caused by what? Electrical source. That's what I'm talking about. So it can be overloading of the circuits that cause that. It can be excessive current flowing through a particular faulty wire. I've seen a situation before where there was a spark just from a source, and the fire started tracing the wire. From that place, the fire started burning, and it's usually very fast. Fire being caused by what? Electrical source is usually very fast. If it will burn the whole cable or burn the whole equipment, it's going to what? Take, in minutes, everything is what? Everything is burnt to ashes. Arc, flash. For those who are not electrically inclined might not know this, but I will show you what arc flash looks like. Okay? I will show you what arc flash. Okay, you see it like a spark. Okay, so we call it arcing in most cases. Okay, look at this. This might be due to what? Arc flash. So what you will see it with, let me give you a very close way for you to notice it. Sometimes when you try to operate your switch, when you press that switch, you see something like a whitish light discharge, like a spark of very whitish light discharge. That is what arcing. Okay, when when the electric current flows through a different path other than the path that has been created for it, that is what you have arcing. The electric current leaves its intended path and travels through air from the conductor to another. Then that is what we call arcing. So it's just like let me demonstrate that for us to see. If I have a switch, okay, if you have a switch, normally the connection is that if current is coming here, okay, current is entering through here. If I press this switch, the path that this current is supposed to flow through this switch. But what happens, okay, when the current jump through the air and don't jump at this place? What happens? That is arcing. So you can see the way it comes, like an arc. This is the shape of an arc, okay? So that is why we call it arcing. It will come like an arc. This is where the current is supposed to be. It's supposed to go straight like this. But maybe this line is already 40 or is actually small to the what amount of current I want to pass, you just see the current will just jump with a flash of light. Okay, just like your lightning, you jump and it will form an arc like that. That's what we call it what arcing. Okay, it's not a deep electrical cause, it's just an inclined. I would have delved deeper than that. Now let's look at the evaluation of risk that we are talking about. You should know that what not all risk is equal. All risks are not what equal. I'm going to show us a particular diagram here. All risks are not equal. Okay, so when you're analyzing the risk, okay, of the electrical fault, you have to analyze it with the probability of an injury occurring. And if this injury should occur, what would be the severity? So in other words, what we are saying is that what risk is calculated by probability multiplied by what? Severity. Okay. Now, what are we talking about? What is the probability that this equipment will result to what? Electrical accident? So, how to calculate the risk? You need to first know the probability. Take, for instance, a well-guarded electrical equipment. We have a low probability to an electrical equipment that is not whose connection is not guarded. So if I open all the connection and the wires are like this, okay, I've just increased the probability of electrical accidents. So there will be probability. Now, sometimes probability might be low, but you now ask yourself again, eventually, if this electrical accident actually occur, how severe will it be? Severity will not be telling you. Will that be just a shock? Will that be just a shock? Will that be burns? That's the question that severity will be answering. Okay. Will that be, electrocution? Will there be contraction of muscles and the likes? So you begin to answer all these questions. That's when you test out the severity. How severe will it be? That's what we are talking about. So you identify the hazards that could lead to injury or that could lead to death. That's what we are talking about. You have to identify them. This can only cause injury. This can lead to death. So it will help you to know how to actually safeguard the equipment or protect the employees or protect yourself against electrical accidents or electrical fault. Okay, so look at this diagram. I just hope we can see this. Now this is the evaluation of risk. This is what you will see in most safety analysis when it comes to risk assessment or hazard risk assessment. So you will see this diagram. Now this column is dealing with probability. You can see where I put the red. You can see probability there. This one is dealing with how severe will it be. So what is the level of the probability? We have low, we have medium, we have high. What is the level of severity? We also have low, we have medium, we have high. So when you take a particular hazard, that particular electrical hazard now, or any hazard whatsoever, anytime you are doing a risk analysis or risk evaluation, you have to get what is the probability. Is it low? Is it medium? Is it high? And what is the severity? If it eventually occurs, how severe will it be? Will it be low? Will it be medium? Will it be high? So that you will know, okay, what to do, okay, and how to actually control it. Take for instance now, look at this practice, this one now. This person wants to replace a 120 volts, want to replace a 120 volt AC equipment, want to replace it, and then when the analysis of the risk was actually done, it showed that the probability of having electrical fault or electrical accident from this is low. So you can see that it falls on low probability. It also falls on low that if it eventually occurs, how severe will it be? It also falls on low. So when you plot this, you see that it is low probability, low severity. And that's the kind of what, risk that you can take. You can take this risk because eventually you can see that what is very rare for electrical fault to occur due to this. Electrical accident to occur due to this. And even if it occurs, the severity is low. So then the company can say, okay, this kind of job, perhaps the employee will just wear PPE, then what? Go ahead to do the job. But look at this. The one of repair of 230 AC motor. Okay. What do you see here? You see that when the probability follows, can we see my screen? Can anyone see what I'm doing?
Yes, we are seeing it.
You can see if you check probability, you see that what the probability of the electrical fault here, the risk from here is on medium. And then you will see that what the severity is also on medium. So you will see different color. The blue color you are seeing here means that what anyone that fall under low probability, low severity is safe. You can work on it. Now the color column was changed when it comes to what probability being medium, the severity is also medium. Because here now we know that what something may actually go wrong. It has already fallen on the medium. So here we have to take in, even though we are going to go ahead with this kind of job, there must be a lot of things being put in place. The line clearance, the PPE, the procedures, everything must be put in place to safeguard the life of the people that will work on this equipment. But look at the story. The story will change when you come to installation of 7.5 kVA transformer. Now we now did the risk evaluation. The risk is high. Can you see that? It's coming from high. And if eventually electrical fault should happen here, what is the severity? The severity is high. This kind of job, don't try it. That's what we are saying. So you can see how risk evaluation will expose the kind of job that is dangerous. So it means that if we are going to work on this, we have to de-energize it. We can't work on this 7.5. We can't be doing the installation when the supply is actually on. That's what we are talking about. Evaluating the risk here shows that the risk is actually high. You can't be working on the live cable that is going to be feeding 7.5 kVA transformer. The probability of electrical accident is high doing it. And if it eventually occur, probably it will lead to death, not even injury, death. That's why the severity is also high. So that is how. So you can always plot that particular that you can always make that practical. And that's what I'm going to actually demonstrate now. Is there anybody that wants to volunteer? I need somebody to volunteer. You will give me, let me tell you what you are going to give me. Give me a particular industrial related electrical work. Okay, you can give me like 1 or 2. And then we are now going to try to plot it. Can it be done when the supply cable is energized? Is there anybody?
All of Intola, I can see your hand. You can unmute yourself. All of Intola, are you there? Okay. Good evening, I'm here. The one I want to talk about is when we have 7.5 kV compression. Okay?
Okay. 7.5.
3.5 kilowatts electric compression.
3.5 kilowatts compressor. Okay. So do you have any other one? Do you have any other one?
And 10 kilowatts.
Okay, 10 kilowatts.
Yes.
Now, let's look at this as you want to perform maintenance. Which of them you want to perform maintenance? So we are looking at them being what? Live cable. So let me zoom this now. Where does it come? If there is supply, if the supply is on, where will your 3.5 kilowatt compressor fall on? Under probability. What is the probability of electric what? Accident on it when it is energized?
I'm looking at it. I think it's
low, medium, or high?
That's medium.
Medium. You have worked on it before. Medium. What about the severity? If eventually electrical accident now occur on it, will the severity be low? Will it be medium or high? What can happen? Why do you say medium? You cannot kill.
It's probabilities. Yes, yes.
It cannot kill.
It's medium. It's very good.
Okay. Severity will be medium. Okay. But what is the probability?
It can kill 3 feet. 3 feet, it can kill.
That's what we are talking about. So what is the severity? The severity is high.
The severity should be high.
The severity should be high. I'm just being practical with you now. You need to analyze the job that you are doing and know I'm actually showing you how to do your own risk evaluation. This is a practical class. You need to be able to evaluate so you can see now others are contributing. Because it can kill. It's 3-phase. What we are talking about is what? 415. Especially if you now have it complete. If it's not the one that drops to 380 like some that you are going to use your meter and going to show 380 or so. If your 415 is complete, just imagine 415 flowing through you. Because I know for you to perform the maintenance, you have to what? Use your spanner. Is that also on the terminals and all that? So the severity is high. But what is the probability? What is the probability? The probability is medium. So that means that what is going to be here. So look at it. So if you bring it here, your 3.5 kilowatts will be here. So if you trace this, probability will show that what? It is from medium. Can we see this? Probability is from medium. Can we see this?
Let's go ahead.
Severity is high. So look at what is fallen. So you can always plot like that. I'm just showing you now that what? It doesn't have to be medium. It doesn't have to be high. One can be medium, the other one can be what? High. One can be low, the other one can be what? Medium. Either probability or severity. Now, where will you put your 10 kilowatts? What is the probability? Anybody can help. What will be the probability on 10 kilowatts?
Are you there? I've been hearing your voice. Yes, sir. Yes, sir. Okay, please contribute.
So if
the probability will be high. The probability will be high. And also the severity will also be high.
Okay, so your 10 kilowatts.
Because it demands a higher voltage.
Okay, that's it. So this kind of equipment, you need to de-energize it.
Yes.
You need to de-energize it. You can't work on a live cable like this. Okay. How many of us work on our electric socket at home, even without switching off? Is there anybody that has done connection on or software?
Yes. Yes.
Okay. Normal. Okay. Now look at that now. Look at that now. You can plot that here, working on sockets, your socket at home now. So what will you give that? What is the probability? Why are you trying that? You know it's not de-energized. You did not de-energize it. You did not switch it off, even though it's still a wrong practice. But now you're actually we are doing evaluation of the risk on it. What will be the probability of you receiving shock from your socket?
Medium. It will be low. Low.
Okay, I agree with that. Now, eventually, let's say you now receive electrical, accident. There's an electrical accident on it. What can it do to you? How severe will it be? Will it be low, medium, or high?
Medium.
It can be medium.
It will be low or medium. It depending on the resistance of your body.
Okay. You got me laughing. The resistance of your body.
Okay, please let's organize. We want to speak, just indicate, signify rather. I will call you.
You will tell us how to calculate the resistance of the body. But look at that. Your socket, your 30-amp socket, okay, actually fall on this place. So somebody is actually doing that. I'm not encouraging that. But we are just looking at it based on what the risk was evaluation. Okay, somebody working on this might just say, "Oh, let me quickly connect it," and you might actually say you are doing that, but you can't try that with all these 7.5 kVA transformer and all that. That's what we are saying, because the probability is high, the severity is also high. Now let's look at types of electrical accident. These are the types of electrical accident. Shock. Okay. Anyone here? Go to the comment section if you have received electrical shock before. Okay, I know it should be almost all of us. Electrical shock. Yes.
It's common.
Electrical shock. Anybody? Go to the comment section. Can you see my screen?
Yes. Electrical shock.
Shock. Everybody is saying yes. Okay. Let me step it up. So let's look at the second one. Bonds. Electrical bonds. You have added bonds due to electrical fault before. Maybe you touch a very hot metal. Okay. Let me analyze them first before I ask you. Let me take them one by one. Okay. Let me take them one by one. Okay. So if you have had bonds before due to electrical, 5 years, let me see that. Anybody that has been burnt, you felt the burnt of maybe there is an electrical burnt, maybe hot. Yes, I have some yeses here. Okay. No burns. Okay. Anybody who has witnessed fire incident due to electrical spark or fault before? Anybody here? Electrical, yes, fire being energized by electrical. Oh, lot of yeses here. I won't say that's great. It's not something to be encouraged. Explosions due to electrical spark. Explosions. Type no if you have not witnessed before. Explosions. Joseph, are you saying something else? Joseph, can you unmute, please? Mr. Moderator, please let me call Joseph out.
Yeah, I'm there.
Okay. Did you say yes to explosion?
Yes, I actually witnessed one.
Tell us how it happened.
I don't know what really happened or what really caused it, but it was a very loud bang. So scary, and there was fire everywhere, as if it was fireworks on top of the electric pole.
Wow.
It was really bad. It wasn't a sight to behold, honestly.
Wow. Thank God it didn't happen to you. You saw it happening to someone else.
Yes, they were guys. Scary, honestly.
Thank you for sharing. Okay. Arc flash. How many of us guys have felt arc flash before? I need to bring up something on that arc flash. I think I have something on arc flash. Something is also very scary. You must have, if you have worked on a very connection before. Okay. Arc flash incident. Can you see on my screen what I'm displaying? Look at this. Look at that. This is the result of the arc flash. Okay. Okay. Just come like an explosion. That one will also come like a flash, like a flash of light. You know, it does happen sometimes. If you have done it before, if you use the red cable, live wire, to touch the neutral wire, you must have seen what I'm talking about. Or maybe mistakenly they touch each other in your presence. Then you see, you can see it. You have witnessed all of them before. That's not fantastic. So no, the last was not. Let's mute, please. Mute, please. The last but not the least is what falls resulting from electrical injury or incident. And this happens a lot when you are doing what electrical work that has to do with what work at height. Falls, when somebody fall off due to electrical work, fall is a scary sight. It's not something to witness at all. Now I want to just show us for you to see the effect of electricity due to the measurement of the what ampere rating of them. You can have a tingling sensation, just a tingling sensation. I know many of us must have felt that before. It will be as if the electrical, the current is massaging your finger. The feeling may not travel beyond your finger. So if the current rating is between 0.7 to 1 microampere, okay, if you have milliampere of 0.7 to 1, what you will just feel is tingling, just tingling sensation. Okay, slight shock. You can have a slight shock, but not a painful one. Okay, you may not lose your muscle control with it if you have experience. If you are exposed to 1.2 to 1.8 milliampere of what current. Okay, shock, a painful shock this time around. Okay, but yet your muscle is still what secured. That's when the current is up to 6 to 9 milliampere. Okay, shock now, not just painful, but a severe one. You feel that there will be muscle control loss, there will be breathing difficulty. Okay, there will be onset of let go threshold for you also. Like that's when you get exposed to 15 to 23 milliampere. So you can see this. Possible ventricular fibrillation. Okay, that's when you are exposed to about 0.1 ampere, okay, of current. So you can use this to know when you are working on equipment, like the first person that answered the question when I was asking about how do you differentiate the 13 amps and the brilliant answer is that one, all equipment, when you take your time to check them, you see the current rating on them. And with the knowledge of this class, you can see what you are open to. If this should actually come in contact with you or you are exposed to it, what should you expect? That's what we are talking about. So you should know the one that can give you what? Just a tingling sensation, the one that will give you slight shock, the one that will give you what? A very big shock, not painful, severe shock, possible ventricular fibrillation, possible heart muscle activity seizures. Okay, seizure of what? Heart.
You should also know about that. That's the one of 0.5 watt ampere rating. Okay, and tissue and organ burn is one of 1.5 watt ampere. So when you look at what the current rating, you should know what the extent of danger that could actually what occur to you. So I have them being itemized here, so you can see what is the what effect on person. 0.5 to what 3 milliampere, tingling sensation, 3 to 10, muscle contractions and pain, 10 to 40 milliampere. Let's go threshold. If you have felt down before, that's you wanted to actually what to drop the cable, but it will just be as if you are magnetized. For those who are deep into electrical, you'll be talking about electromagnetism and all that. Like an induction. It turns the conductor to an induction to magnet, to a temporary magnet, and then for you to let go will be very, very serious. So I think I've actually experienced that before. And when you come out of that, it's just it just decreases. Though my own was actually domestic, I've always been very careful when it comes to industrial safety. I've always been very careful. And the one that I even experienced domestically was very, very many years ago. Even before I got to have a deep knowledge of electrical, I was still very, very little. So I'm talking of many years ago. But I still have one. The memory is still fresh because it was a very terrible experience. But I've always been taking my electrical safety. I don't take it with a joke. And that's what we are actually doing with this training. So the burns can be thermal contact. So when you have your skin, touching the overheated electric conductors, this can be from your hot plate, or if you have any hot, an electrically powered hot metal or hot equipment in your place of work. For example, in my own place of work, even though it's not electrically fired, but there is a lot of electrical equipment that is working with it. We have cane. That's in cement plant. We have cane, rotary cane. We call it rotary cane. Okay, and when it is fired, you're having about 1,000. It is fired up to about 1,450 degrees Celsius. To the extent that when you are passing under it, you are passing. The rotary cane is always very high up. When you are walking beneath, you will feel even some meters away from it. You will feel the radiation of the heat. Okay, so these are thermal burns. If you suffer burns due to this, if they want to maintain the cane, they shut it down for like 3-4 days. It's still cooling down. Nobody can go near it. Okay, so electrical burns also. We have electrical current flows through our tissues. When electrical current flows through your tissues, there will be burn. There will be burns, and the skin deep or affect deeper layers of your muscle. That's electrical burns. We have arc burn. I just showed you arc burn here. Okay, in this diagram, you can see arc burn. This is burns. Look at this palm. Person was actually work. So you just hear this one is just like when you see the those people that do welding work. Okay, when you see that light that is coming out of them, so the arcing light is like that, and then it just comes like that, and then you have the burns. Look at this person's armpit here. The arm and everything. That's a serious burn here due to what? Arcing. And you must note that the three of them can happen together. You can be exposed to the burn due to thermal contact, due to electrical, and due to arcing. The three of them can actually happen all together. So hazards. Let's look at the controlling hazards. So we should know that you can control hazards. And you may also, let's say that you can minimize the risk, okay? Number one, by creating a safe work environment. It is very important. If the work environment is safe, you will be able to overcome a lot of hazards, okay? If all the connections are properly done, you can overcome what? Electrical hazards, a lot of them. If the floor is not wet, you can overcome a lot of electrical hazards. If the equipment are all the electrically energized equipment are properly what? Covered. Okay, when you have their cable being joined together, it's just like you having your junction box at home without being covered. So there are situations that when you get to plant, for people like me who are in the field of safety, that go into company and help them to look for loopholes of their safety culture. So we check it for them, and then we tell them, we recommend, oh, you need to improve on this, you need to improve on that, you need to do this, you need to do that. For some of us that do that, you will see that your awareness of what electrical faults or things that are not right, your awareness will be very, very high. So when we walk around like that, we can easily spot things that are not being done right. Oh, this is not good for your work environment. Can you change this? Can you replace that? That socket, this? Most of the welding sockets in some industries are not properly installed. Okay, most of the equipment are not properly plugged in. If they are not properly plugged in, this can increase, it can generate more heat than necessary. Okay, if some cables that used to connect some equipment due to their current rating, if the cable cannot support them, you should be able to know that there will be overheating through the cable, and in a very severe condition, this may actually generate the cable can get burnt along the line. So the work environment is a sensitive place that you need to first put everything right first. So if the environment is safe, you can guarantee that 75 or 80% of the electrical accidents that may occur can actually be mitigated or minimized or controlled. Using safe work practices. What about the practices of work? If the regulation says for every electrical worker you must use your hand glove, then you should know that using your hand glove becomes very, very paramount. You must not be seen. It's just like the health workers. Before you can attend to any patient, you must put on your surgical glove. That surgical glove is to protect yourself from germs. You also, as an electrical man, you must use your glove. If that is the regulation of your company, you not say that this one cannot touch me. I'm very confident. How many years I've been doing it, nothing can happen. I will touch it. I've even heard of people, who can actually place bets on the fact that they can, I don't know how they got their own experiment, or maybe they find it in a physics textbook or anywhere, that when you seize your breath, electric shock you can't feel electric shock. That's a very dangerous idea or proven hypothesis for anybody who wants to uphold electrical safety. For you to say that when you are going to touch a light cable, you seize your breath and nothing will happen. That is wrong. It is not the correct practice. So the practices must be right. If we say that people must take line clearance before they can go and work on equipment, like the story of that my friend I shared with you, you must adhere with that rule. Violation to that rule should attract punishment from the company, management. In the industrial management should frown at anybody, even though you have done the work, you escape the risk, nothing happened. That doesn't mean that if you continue like that, it won't happen one day. So if you must wear your glove, wear your glove. If they say this place, helmet is needed, wear your helmet. So that is what we talk about. The best method is for you to keep it a safe work environment, for you to actually uphold the safe work practices and being properly trained. That's another problem. In most cases, we assume, I already mentioned that from the beginning of the training, that induction in every company is necessary. How many of us Leave your company today and go to another company. It is very, very, required that you should also still be trained based on the environment where you are presently working. So, limit exposure. We are talking about you should reduce the amount of time spent around high energized equipment. It is very important. So you should limit your exposure. The time interaction should be very, very low, should be small. Maintain distance. When you have a highly energized equipment, you maintain distance. You need to know that when you have transformers being installed all around in your company, you shouldn't walk too close. Many of us in the theoretical aspect, I don't want to go into it. There are heavy currents, there are flux linkages that can actually happen around your transformer. So you don't need to, most of the accidents and deaths from transformer that I've heard of, even the person doesn't need to touch it. Okay? In high tension, there is what we call corona effect. Corona effect. That's to tell you that all the air that are around the world and electrically energized conductor, all the air that surrounds it, they are ionized. They are also charged. They are prone to charges. So that's where you'll be hearing the sound when you pass through your front of very close to your transformer or any high cable that is carrying high voltage. You'll be hearing all sound like something like that. That's what we call corona effect. Okay, so to maintain your distance, okay, when you are walking, you can also bring a particular mass in between you and the equipment in case there will be explosion. And if it is required in your company, then you need to wear your PPE properly. You need to learn how to wear your PPE properly. In fact, I encourage people, even if your company did not give you, you can actually get some for yourself, so that you can keep yourself safe. It's very important. Now, let me quickly talk about this before I allow questions and all that. What are the protections against electrical hazards? The first one is the insulations. You can use insulations. I've talked about that. Insulations are poor conductor of electricity. So if we coat or we cover a good conductor with a material that cannot easily conduct electricity. So that material that cannot easily conduct electricity is called insulation. So one of the ways you can actually achieve safety is for you to, cover a good conductor with a poor conductor. And that's when you see your plier. You can use your plier, to twist your light cable together, because the handle of your plier, okay, the place where you put the effort of your plier, it is actually insulated. Okay, and it is not even ideal that you use it to twist light cables. I'm only saying that it's actually the insulation was placed on your plier, so that in case you don't even know that there are supply there. It's not meant that you should really be using it to twist light cables. I've said it time without number that you should try to work on a dead circuit. Do your best. If you can actually shut it down, let it be that you are working on a dead circuit and not energized circuit. There can be guarding. Guarding means that you can provide a guard around the equipment, so that your hand cannot touch the cables, your hand cannot touch the light cable or the exposed part of it. You can put a guard around it. Grounding, you can connect the body of the equipment to the earth. In case there is leakage current, then it flow to the earth. The grounding is like creating a part of low resistance, to the flow of current. And you know that current will always be attracted towards a place where there is low resistance to it, just like human being also. you would like to go to a place where they are not pushing you back. So if you have what a part of low resistance for the electric current, you can save the other body, which is you in this case. So we can connect to the ground because ground is a very good conductor of electricity and it has what a very low resistance to the flow of electric current. And we have what electrical protective what devices. Those are your what your devices that can help to safeguard, in case there is maybe an overload, okay, or a short circuit. We're talking about your fuses, the fuse can blow out. Therefore, discontinue the flow of what electric current, and then there is what safety. We have circuit breakers. Many of us have these. You are interacting with it in your industry, or even in your household. We have what? We have a grand fault circuit interrupters. We call it GFCIs. So what happens when there is what? The grounded fault, earthing fault. So these interrupters are the ones that will actually help, okay, to still save what? The equipment, or to save you from what? Being what? Electrocuted or being exposed to what? Electrical what? Accident or fault. So let's take it here. We have a whole lot. Tomorrow we will pick it up from where we stop. I'm going to be diving into the electrical safety, talking about what the PPEs that are needed for you and how you should properly wear them. We are going to be talking about what Lotto itself, log out, tag out. I've mentioned some part of it today, but what are the necessary steps and procedures that are needed for you? And tomorrow I'm going to be dealing with what? Fire safety. Also, what are the required what skills? Okay, the required what techniques from you in case there is what fire incident resulting from what electrical, source or electrical fault. How do you fight this? And so many other things that we need to actually work cover. So everything will be covered tomorrow, talking about what energized electrical and all that. We will discuss all this tomorrow. So I hand you over to the moderator. So if there are any questions for me. Thank you.
All right. Want to appreciate resource person, Mr. James Honey, for that wonderful. So far, yes, has been a very, very engaging, quite an engaging and interesting class. Okay, so questions. Okay, it's time for questions. So please, if you have your questions, kindly indicate by raising your hand, so we can use the little few minutes we have to attend to that. So questions, please. If you have questions, please signify by raising up your hand. So I'll call on you. And those who are on the YouTube live platform, please, if you have your question, kindly drop it in the comment section. Drop it in the comment section. All right. Okay. So I can see Augustine Obeng Arthur. I can see your hand. Just a minute. Okay. Mr. Augustine, I can see your hand. You can unmute your mic. Blue Spring Hotel, I can see your hand.
Okay. I'm Blue Spring Hotel. Can you hear me?
Okay. Yes, please go ahead.
Can you hear me, sir?
Please go ahead. I can hear you.
Okay. I'm having this issue with my my oven, electrical oven. I used to bake bread. So, like, when I'm using tester, there's current. It's shocking. So I don't know where the fault is coming from. I've checked the panel. There is no fault there, but the panel, the oven is still shocking. want you to help me out. How can I fix it?
All right. Thank you very much for your question. Okay, so we have a question in the comment section as well. Sir, please, what level of voltage do we have? Do we call it industrial electrical? Okay. And then the second question in the e-message section, what will be a safe distance? That is a safe solution walking around a high voltage or transformer. All right. Okay, so one is asking, how can I get notebook to go through? Okay, we'll get to that in a bit. Kindly explain what's the voltage. Okay, all right. So let's see what we can do. Questions might not be able to take everything, but some of those questions they are just very straight jacket answer. But I will give something the honor to respond to those questions. But before then, let me quickly go through YouTube, our YouTube page to see if we have questions from that end. So far, there are no questions from our YouTube audience, so I think we can proceed with the questions we have here. So I would like to bring back our resource person. Our time is fast spent, but Mr. James, I would implore you if you can respond to those questions within the next 5 minutes. Like just additional what
I can't hear you, sir. Your voice is kind of shaky, kind of. Mr. Can you hear me?
Yes, I can hear you, sir.
Sir, I didn't hear your narrative, sir.
Oh, okay. The questions. All right. We have some of them in the comment section, and the person who asked this question via the audio was asking that yes, he has I think he has a freezer that is shocking, that he has tried he has checked all the components that they are working fine, but it's still shocking when you touch the body. That what could be the problem? So I guess that's what this question is about. So aside that, we have 1 or 2 questions in the comment section as well. So the first one is kindly explain to us a step voltage. That's one of the questions. And one equally asked, there's another question that's from what level of voltage do we have it called industrial electrical? All right. So we have about 3 questions in the comment section, sir.
Okay. Let me see if I can share my screen. So I will do the little I can by the permission of the So I will do the little I can do by the permission of the moderator. So I want to first appreciate everyone that joined us on this training. Thank you so much for being part of this training. The first question, as captured by the moderator, somebody was asking about electric oven. I think there are few things that you can actually check in your electric oven. However, if you are not experienced in repair, I would advise you that you should not, because sometimes people want to believe that I'm an electrical person, I should be able to do this myself. Yes, it's good for you to challenge yourself. However, when you see that you can, because electrical fault is not something to toy with, really. You really need to understand what you are doing. So having said that, anyway, so there are a few things that you would have to do. But at first, try to disconnect before you do these few things I want to just recommend for you. So get access to the main circuits and the wiring of the electric oven. So you check it to see if there is no faulty wiring. So sometimes when the wire melts, okay, or you have the live cable and the neutral cable touching each other at one point or the other inside the circuit, so you may be receiving shock, okay, because the voltage will not be what balanced. So that's like a short circuit. So when you have live cable, touching the neutral cable, that's a short circuit. So you can actually be receiving shock, and that's very dangerous. So you can also check for the grounding issue. So suppose the body of the electric oven that you are using, the bodies of that's supposed to be non-conducting, or that's supposed not to be conducting, rather electric current is supposed not to flow through it. So if the wire, some part of the cable that you are using, the live cable, has touched the body of that particular oven or the equipment, and the grounding is actually faulty, don't forget, I don't know if it's in this class I explained. So grounding is actually connection of the conducting parts of the circuits to the ground. So connecting the conducting parts of your electric circuit to the earth is what we call grounding. And why do we do that? In case of what current faults, okay, if the current flow through the part that is supposed not to go through, so that the person working on the equipment can be safe. So you can check out for grounding issue. Another thing is sometimes overload can actually what cause that, some trigger like that also. So if you have like an excessive load on the equipment that you are using, that can also result to that. So if it's only shock that you are actually seeing, so check for all the cable, inspect those cable one by one, like from little distance to another distance, for you to be sure that they are not really they have not joined together at some point, and the live cable has not peeled or touching the body of the circuit. So you can try that. But aside this, try to actually seek an experienced hand to assist you, because if we see the equipment now, I think we can see it physically. It's something that we should be able to trace out. So it's not like the power is not getting there, it's just that it is actually short circuiting. So that's the short circuit that you have there. So another question here was asking about a step voltage. So let me briefly show you what a step voltage actually looks like. So if you have a cable, let me share my screen, sorry. So when you hear the term step voltage, it's actually a fault, okay? But step voltage is talking about the difference in voltage at one point to another, and in most cases is a distance of let me say about 1 meter, okay, about 1 meter or 3 feet or thereabouts. So if you measure voltage at this particular point, let's say you have a cable like this, normally the voltage through this cable is supposed to be constant, it's supposed to be even. What I mean is that if the voltage flowing through this particular cable, let's say it is 240 volts, okay, at any point in time, if you measure the voltage at any point in time along this cable, there should not be any voltage drop, okay. It should actually be able to there should not be, let me say, there should not be a conspicuous voltage drop. There should not be a too glaring voltage drop. So even if there will be a drop, it should be something negligible. But if you find out that at this particular point on this cable, you measure the voltage, at this point also you measure the voltage, okay. So the difference between these two voltage, let's say this is about 1 meter or 3 feet or thereabout, or 3.2, 3.3 or thereabouts. So if you measure the voltage between these points, okay, if you measure the full voltage, let's say there's a difference of let me say 20 volts. So that these 20 volts I just wrote now is called step voltage. Sometimes you see it being referred to as a step potential. So it's actually a significant fault. So if there's a fault in the electrical system, you can have a step voltage. Otherwise, if there's no fault, you shouldn't have anything like step voltage in that. Somebody also asked about the level of voltage that we can refer to as a industrial voltage. Okay, well, across every industries, okay, we make use of voltages even right from the single phase voltage. So we all know that the normal voltage for the single phase is actually 240 volts. So even across those region that you can say, oh, these are industrial region, or you can say this is an industry, there are still some equipment that make use of single phase. Okay, they're like your fan. Okay, the fan that you have across industries, most of the fan, they still make use of the single voltage. The only thing is that what they make use of the single phase, rather. The only thing is that what they contain capacitor, because you know that for electric motors to give a rotation, or for electric motor to provide rotation, the flux, the magnetic flux inside this must be a rotating magnetic flux, not a static magnetic flux. For those people that are core in electrical, but I suppose the person that asked the question should be a deep electrical inclined person. So for you to provide rotation in an equipment, the kind of flux that you need there, okay, that results from the magnetism, the kind of flux that you need is a rotating magnetic flux, not a static magnetic flux. Now, before you can have a rotating magnetic flux, you must have more than one phase. Just a single phase cannot provide or cannot generate a rotating magnetic flux. So hence, it is very important for us that if we want to feed an electric motor, you want to feed it with a single phase, which you know that what it will just be only one live that is coming in. So we have to create a situation in which there will be a capacitor. You know what a capacitor does? Store charges and release it gradually. So we need a capacitor. This capacitor is what will now come in, so that what it will appear to the electric motor as if we are supplying what two phases, whereas it is actually single phase we are what supplying. So what does that mean? We still make use of your ceiling fan, the electric motor in your ceiling fan make use of a single phase, but there's capacitor there so that it can become a rotating magnetic flux, so that your fan can see it like it is two phases that is coming in. Okay, so your blower, okay, the blower that we use in the industry, okay, to perform a maintenance and all that, they use was single phase. So even from single phase voltage, okay, you can still see them across industries. They are also industrial voltages. The only thing you can say is that in the domestic area, okay, a place of residence, okay, it is not ideal for like more than one phase to enter a particular house, except that different flats there are using different phases, and it's not really illegal. Okay, so that's why you see that you can be in the same building. This apartment has a power supply. Aside isolation, it might be that they are connected to different phases. It happens like that. So you cannot see, like, you shouldn't see like three phases like that in a domestic area, but from single phase, three phases like that, you can begin to see it across industry. And when I'm talking about that range, it means that from 220 volts to 40 volts, because there are sometimes that your single phase voltage will not be complete in some area, especially in Africa. Yeah, so when you test, you may not see that complete 240 volts because of voltage drop. So you may be seeing 220, even sometimes 180. I've seen 180 before, and they are still using it, although it's not ideal. But from 220, 240. Okay, some electric motors are using up to like 660 volts. So you will see it. Some electric motor actually will use that. You can see 415, which is what 3-phase. The medium voltages, you can begin to see like 1 kVA, 1 kV, that's 1 kilovolts. You can see about as high as even 11 kV sometimes across some industry, depending on what the industry is into. But all these voltages I mentioned, they are also they can be called industrial voltage. You can make use of them across the industry, depending on the equipment that you are using it for.
All
So I
right.
don't know if I have any other standing question.
Thank you very much, Mr. James. Yes, time is fast spent. So we have come to the end of this class, the end of today's class. Yes, someone is saying another question. What we are going to do is we'll take those questions, just drop them on the WhatsApp platform. Yes, we can follow up on those questions from that end. So please, if we've not been able to answer your question in this class, please copy it, drop it on the WhatsApp platform. We'll respond to it on that platform. And if time permits us in tomorrow's class, we can as well respond to it in tomorrow's class. All right. So yes, someone is asking if the notes material is going to be given. Yes, we are going to be sending the material alongside the certification. So please take note of that. At the end of tomorrow's class, there will be an assessment. Your assessment covers everything that we have that will be taught, that has been taught in today's class and will be taught in tomorrow's class. So please, what you are required of in that assessment is to do a performance of 60% in the assessment. So this will guarantee that yes, you understand what has been taught, and it's also a requirement for you to get in the certification for this training. So information regarding the certification, we'll be dropping it on the WhatsApp platform as well. So please, when the document is being dropped, just look through it. Like I did mention at the beginning of the training, it's not something you need to wait the bank for to get. All right. Okay. So on that note, I want to appreciate everyone for being a part of this class. So we are going to be using the same classroom link for tomorrow's class. Okay. So there's no new link. It's only the YouTube link that is going to change. And we are going to be dropping the YouTube link for tomorrow's class on the WhatsApp platform. So subscribe to our YouTube channel. So you don't even need to wait for it to be dropped. You definitely get ample notification when we have our live classes coming on board. So please subscribe to our YouTube channel to follow up on more of our training videos. So thank you very much, everyone. All right, Mr. James, our time is fast spent. I can see your answer.
Pardon me, I don't know. It is just a straight jacket question. Somebody asked a question. It's just a straight jacket one. I think the person was asking about distance. I don't know how I skip that. About a safe distance from high voltage and all that. Please, let me say this. I think we are still going to re-emphasize it tomorrow. Please don't be measuring distances. Although there are standards that talk about distance. Follow your lotto very well. Follow your lotto before you can go near what an high voltage what area, because you know that what in this high voltage we have what we call corona effect, which means that what you don't even need to actually touch. Okay, there are charges around the place, and even in your transformer, of course, you will know that what we have leakage flux. There are flux that can actually what leak. We have leakages. Okay, the flux can actually leak, which means that it makes the surrounding of your transformer to become what charged. Although there are standards based on where you actually work. For example, for 600 volts, I think about 1 to 3 feet, okay, distance is actually considered safe. It is considered safe. It doesn't mean that what you should dare, because you may not actually come back to tell the story. So depending on the voltages that you are working with, and every industry should actually have that policy. So if you are working in that area, it will be specified for you to know that what this is the safe what voltage. I mean safe distance from this particular voltage. But please, if you have to do anything, it shouldn't be that what you say, I'm already safe. That is not ideal. Don't say I'm already safe and you're not standing there. No. Make sure that you do your lotto before you go near to actually do anything to ensure that it is safe for you.
Thank you.
So please, sorry, Mr. Moderator.
Thank you very much, sir. So on that note, we are dropping the class here. So see you again in tomorrow's class. So please drop your feedbacks on the WhatsApp platform. Your feedback of today's class, please drop it on the WhatsApp platform. Thank you very much, everyone. Do have a restful evening. Do have a restful night as well. See you in tomorrow's class. Bye-bye.
Thank you, everyone. Bye.
Thank you, everyone.